Hi, today we're going to be doing trig values again, but we're going to either be doing the values of the sine of two angles being added, or cosine of two angles being added, or tangent of two angles being added, or the difference of two angles being subtracted, like the sine of a minus b, cosine a minus b, and tan of a minus b. Or we're going to be doing the a single angle and finding the value of the sine, cosine, or tangent of a double value of the angle, or the sine, cosine, and tangent of half the value of the angle. Now, all of these formulas will be given to you on the formula card, so you do not need to memorize these formulas. You just have to know how to use them. All right, so for example 1, if A and B are positive acute angles, so we're talking about two totally different angles, doesn't even have to be in the same triangle, that sine of A is equal to 4/5 and cosine of B is equal to 12/13, find the value of cosine A plus B. All right, well, first we have to understand that we're dealing with the sum of two angles trig problem. So that means to go to your formula card. And you go to your formula card, you find that formula, and then you're going to use that in its place. So for this formula, you need to know 4 pieces of information. You need to know what the cosine of A is. You need to know what the cosine of B is. You need the sine of the A angle and the sine of the B angle. And then you have to compute the cosine of A times the cosine of B minus the sine of A times sine of B. Well, our given information, we go back to our problem. We have that the sine of A is 4/5. So in place of all of sine of A, you're going to put in a 4/5 in its place. Okay, what else do we have? We have the cosine of B. The cosine of B is 12/13. So in place of cosine of B, we're going to fill in a 12/13. So we are missing the sine value of B. We're missing that. And we're missing the cosine value of A. So I have to figure those out. To figure out a missing value, we actually did this in day 1. We know that if we're given a value and we know what quadrant we're in, we can always label the sides of the triangle with the 2 values of the ratio given and find the third side by Pythagorean theorem. So this is going all the way back to day 1. So first we're going to do this one, the A angle. It's a positive acute angle. Positive acute angles are angles between 0 to 90. So that means that we're in quadrant 1. Now B is also a positive acute angle, so both A and B are in quadrant 1. But we're going to do 2 separate pictures to represent each one. Okay, so the A angle. We know that it's in quadrant 1, so I'm just going to draw any triangle. And the A angle is always in the pocket of that triangle. We know that the sine value is 4/5, so that's the opposite side. That's the hypotenuse. So we now know that the O side, is 4, and the H side is 5, and we're missing this side. So we know that we can find the missing side by doing Pythagorean theorem. And we know that that side is 3. So now we know that the cosine is going to be the A side is 3 over the H side is 5. Now we're in quadrant 1, so that means it's always going to be positive. Okay, moving on to the other angle now, the B angle. Move these over. Okay, the B angle now has different numbers. The B angle is a totally different picture. The B angle is still there. And this time it's the A side over the H side is 12/13. So I know that the A side is 12 and the H side is 13. and I need to figure out that side. So same thing, we're going to do Pythagorean theorem. I'll shortcut that. X squared is equal to 25, so x is 5. So now we know that this is 5. So when I go over here to fill in my sine of b, I now know it's going to be the O side 5 over the H side 13. And it's positive because we're in quadrant 1. So I filled in all the pieces of the puzzle that I need, and now I have to type this into my calculator. So let me get my calculator. Okay, so plugging that into my calculator, I have, let's see, 3 over 5 times 12 over 13 minus 4, apologize, okay, minus 4/5 times 5 over 13. So the hardest part is just finding the missing pieces you need. Then you use the appropriate formula, find the missing pieces, and then the calculation. So 16 over 65 is the value of the cosine of the A plus B angle combined. Okay, example 2. If A is an acute angle, and I apologize, should have said a positive acute, and B is a positive obtuse angle, should have said positive, such that cosine of A is 8/17 and sine B is 2/3, find the exact value of sine of A minus B. So once you see that it's an A minus B formula, then you know you're going to go to your formula card. So anytime you see the sum or difference or double or half involving trig of the angles, you're going to definitely go to your formula card. So sine A minus B. So I'm going to find the sine of A minus B, which is right there, and I'm going to use that formula. So we'll start by writing that on. Okay, so just like before, I just got to figure out what I have and fill it in. I know that the sine A or cosine of A is 8/17. So in place of cosine of A right here, I'm going to fill in 8/17. All right, I also know that the sine of B, right there, the sine of B is equal to 2/3. So we're going to fill in 2/3 here. That's a minus sign. I am missing the sine of A, and I'm missing the cosine of B. All right, so just like before, if I have values for sine and cosine and I'm missing other values, all I have to do is figure out where I am, graph it, find the missing side by doing Pythagorean theorem. All right, so let's do the A angle first. We know that the cosine of A, oh, sorry. Okay, we know that the cosine of A is 8/17. So what I need to know right now is where am I? So I know that angle A is a positive acute angle. So I know that that means A is in quadrant 1. So I'm going to draw an angle in quadrant 1, and there's my A angle. And I know that the A side is 8 and the H side is 17. So I'm missing this side. I'm going to do Pythagorean theorem. So I now know x is 15. So I can now fill in this one right here. The sine of A now is the O side 15 over the H side 17. So now I have to do angle B to find the cosine of B. Well, angle B is an obtuse angle, and obtuse angles are any angles between 0 to 180. So that means we're in quadrant 2. So quadrant 2, I'm going to draw my triangle. Quadrant 2 would be like this. And there's my B angle. I know that the opposite side is 2 and the hypotenuse side is 3. So O is 2, H is 3. Have to find the missing side. Okay, so it's the square root of 5. Not pretty. Please don't use a decimal. Always leave it as a radical. So now the cosine would be radical 5 over H is 3. But this time we're in quadrant 2. So I have to keep in mind, is this going to be positive or negative? So ASTC, we're in the sine quadrant. That means sine is plus, which means cosine is negative. Okay, there are all our missing values. Now I have to compute this. Because of that nasty radical, I cannot put the entire thing in my calculator. But you can multiply these two in your calculator and you will get 16 over 51. For these two, when you multiply fractions, you multiply side by side. So 17 times 3 is 51 in the denominator. And 15 times negative radical 5 is negative 15 radical 5. So all that stuff, we're learning how to multiply with radicals. You've learned that before. And then how to add fractions. You need to have a common denominator, which we do. Then you keep the denominator and simply add or subtract these. But you can't make them one term because they're unlike terms. So we just show them being subtracted in the numerator. So all it is finding missing values. Don't forget positives and negatives, and being able to compute the calculation after you plug in all your values that you need. Okay, example 3. So if angle A is in quadrant 2, so they're going to tell you it's in quadrant 2. So that makes it nicer. We want to figure out what is the value of sine of 2a and tan of 1/2 a. All right, well, we're doing the same problem, but two different formulas. Sine of 2a, if you go back to your formula card, sine of 2a is equal to, let's see right here, sine of 2a is equal to 2 sine a cosine a. Okay, so what I have to do now is find the information that I have and fill it in, and then I have to figure out what I'm missing and then fill that in. So, highlighter, I know that the sine of A is 3/5. So in place of sine of A, we're going to do 3/5. Cosine of A, don't know. So I'm going to do my triangle. We're in quadrant 2 because they literally said we're in quadrant 2. And now we're going to draw our triangle, put our numbers on, and then find our missing value. All right, we have our O side is 3, and our H side is 5. We got to find this side. I'm just going to tell you, you do Pythagorean theorem, but you might recognize that this is a 3, 4, 5 right triangle, so it's going to end up being 4. So now I know that the cosine is A, which is 4, over H, which is 5. And we're in quadrant 2. So sine is positive, cosine is negative. All right, we have all our values. Just got to type this into my calculator at this point. And it's negative 24 over 25. All right, tan of 1/2 A. Same angle A, we're doing the same problem, but now we have to look up the formula for tan of 1/2 A. So going to the front sheet again, tan of 1/2 A is way down here. It's that formula. So we're going to use that to figure out the value of the problem we're on. So positive and negative radical, 1 minus cosine of A over 1 plus cosine of A. 1 minus, the cosine of A is actually, we just found it. It's the one we did over here. So negative 4/5. And then 1 plus negative 4/5. When you're working with the radicals, you want to make sure you calculate the number under the radical first, because you don't know if this is going to be a nice perfect square number or not. If it's not a perfect square, then we can't type it all in our calculator. If it is, we could. So let's try first what's going to end up being. All right, and we get a 9. All right, so the square root of 9 is 3. So that will be actually a nice value. Now, since we're in quadrant 2, that means if we take half of a quadrant 2 angle, we'll be in quadrant 1, which is going to be positive. So for this, you have to worry about which quadrant you're in. Think about what angle is in quadrant 2, and half of 180 is 90. So you're going to be less than 90. So in quadrant 1 is really where it's going to end up being. It's going to be positive 3. Okay, the next one. The sine of 5x cosine 2x plus cosine 5x sine 2x. What they want to know is which one is it equivalent to. Basically, this is one of the formulas expanded out. So I'm going to write it with the A's and B's filled in. So all we have to do is figure out which formula is this mimicking. So sine of an angle, cosine of the other angle, plus cosine of the first angle, sine of the second angle. So going to our front, sine cosine plus cosine sine, sine cosine plus cosine sine. So it's really this formula expanded out, the sine of A plus B. So what do we have on this problem? We don't have any values, but we do know that the A angle is 5x and the B angle is 2x. And if I simplify that, the sine of 7x would represent our given expression, and that would be choice 1. All right, 2 last problems. Problem 5. So anytime you see a trig with a plus or a minus or a double and a half right there, you know it's going to involve the formula. So this is going to be the cosine of the A minus B formula. So you go to the formula card, you look it up, and it's going to be this formula. Actually, I'm going to run out of room, so I'm going to extend the page. Okay, so it's going to be the cosine of A, cosine of B, plus the sine of A, sine of B would be the formula if we look it up. Now, we don't have any values at all. What we only have is the angles. So you have to understand, what piece do you have, the value or the angle? We have that the A angle right here is 180, and we have that the B angle is theta. So that's all we have. We're going to only fill in for those spots. Okay, so then you're like, well, I'm stuck. We have nothing else to do, but we do. Because the cosine of any angle that lands on a multiple of 90 can actually be calculated using the calculator. So we can find those two out using our calculator. Type in cosine of 180. And we have -1. So this is going to be -1 for that box. This guy, we have no idea. So we're going to leave him alone. Plus, this guy, again, we can use our calculator. Sine of 180 is 0. And sine of theta have no idea. Okay, well, -1 times cosine simply means negative cosine theta. And 0 times anything is 0. And if you add 0, that means nothing. So negative cosine would be the lowest we could go. And that would be choice 4. Okay, and one last problem. So last class we did exact values of like 30, 45, 60, and any triangle that contained, or any angle that contained a triangle with those angles. This time in example 6, I want you to find the exact value of cosine of 15. That means that we cannot just simply go to our calculator, type cosine of 15, and give me that, because as I explained, exact value means it has to be perfect, and this decimal, though it's long, but it's not perfect enough. All right, so how do we do that? Well, we know for a fact we have exact values for the 30, 45, and 60. We also could do it for using 90, 180s, and 270s. I told you angles that involve multiples of 90s can easily be done on your calculator. So in order to do cosine of 15, you have to kind of be tricky. You have to say, okay, how can I get a 15 angle using 30, 45, 60, or going up here using 30, 45, 60, or even 90, 180, and 270. So there's actually two ways to get cosine of 15. I can do cosine of, let's see, 30 divided by 2. And that would be, actually, let me say it to you differently. We can do cosine of a half of 30 is 15. Or we can do the cosine of, 45 minus 30. And that would also give me a 30-degree angle, or a 15-degree angle. So it depends on which formula you want to use. It doesn't really matter. You could use now the cosine of a half of A formula, or you could use the cosine of the A minus B formula. Let's look at the formulas and see which one we would want to use. So cosine of 1/2 I would have to use a radical. So you know what? I don't think I want that one. Let's try the other one. It's the cosine of A minus B. That one looks a little better to use. So you have a choice, but I'm going to go with that one. Now I just also want you to see that the cosine of 2A has 3 formulas. You can use whichever one you're more comfortable with. All right, so we're going to use the cosine of A minus B formula, which is cosine of A, cosine of B, plus sine of A, sine of B. All right, so what we're going to do right now is fill in the A angle is 45, because all I know right now, and the B angle we're going to fill in for 30. All right, now the cosines of 45s and the cosines of 30s and all that, we did do exact values of those. We did it last class. We did our special right triangles. So for those, you guys may want to make your chart to do those. So that's where we did our sine, cosine, and tangent. Well, I don't need tangent, so maybe I won't do that one. We do 30, 45, and 60. We know that sine and cosine all have two denominators. And we know that the numerators go 1, radical 2, radical 3, and then backwards. Radical 3, radical 2, 1. So all I have to do now is find the cosine of 45 in my chart. Cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Sine of 45 is radical 2 over 2. And cosine of 30 is 1/2. All right, now I have those ugly radicals. That means I cannot just simply type this in my calculator. I'll get the same exact answer I did when I tried to do it at the beginning. So I'm going to go ahead and multiply those two. A radical times a radical, you multiply the underneaths together, and 2 times 2 is 4. Radical 2 times 1 is radical 2, and 2 times 2 is 4. They're not like terms. That means that you're going to just try to combine them. You have common denominators. You keep 4. And radical 6 minus radical 2, you can just show those two being subtracted, but that's it. Now you could check that. We just did the sine of, we did the cosine, of 15 earlier already. I'll bring it up. But now if we check our value we just got, and oh no, it's not the same. Let's see, what did we do wrong? Oh, I apologize. I see what I did wrong. I covered up the plus sign and then I thought it was a minus sign. Apologize. That should have been a plus sign. Okay, and there's our value again. It is the same. I'll bring it up. So those two do match, but that is the more precise answer. Plus sign. And that's the exact value of cosine of 15.